still there? To delete this message, press 7. To save it in the archives, press 9. To hear more options, press 0. What are you talking about?
Jamie.
Andy, hi, how are you?
Hey, how's it going?
Very good. Nice to meet you.
Nice to meet you. Thanks for making time for today. Let's see. So this is a call to kind of give us some time to get to know each other a little more. But yeah, thank you for joining me, Jamie. It means a lot for you to spend some time with me today. My name is Andrew. I'm a data scientist here in Silicon Valley, but I didn't come here in a very linear route. I bounced around a lot of different industries. I started with startups and natural language processing. Then I went to hedge funds in the fintech space. Then I went to FANG companies. And now I'm in a more niche role in a data science team, much smaller team, but a lot wider field. And I think that that's a good of a example as possible of the fact that anybody can enter the data science field from any kind of experience. So that's the kind of experience that I'm hoping to offer the community, some sort of educational standpoint from understanding how to navigate the field of interviews. I've had 30 interviews in the Silicon Valley space. I've had competing offers every step of the way when I transitioned. And each time I was able to transition, I took those competing offers and increased my base compensation by 20 to 40% each time. So that's why I'm here now, trying to help you understand what you're worth as a data scientist, help you get the best offer possible, and help you navigate the ins and outs of every single interview step. From the very first technical call to the last virtual on-site, of course, in the pandemic.
Yeah, wonderful. Well, congrats, by the way, on your journey. That's fantastic.
Thank you.
Yeah.
So if you have 10 seconds, or maybe I use more than 10 seconds, so up to you. Anything you want to share about your data science journey?
Yeah, definitely. I think I'm probably arguably like at the beginning of it, if you will, really looking towards data science to either do one of two things. First is either to continue within consulting, and that's kind of been my career path so far, if you will, since grad school. Kind of like the second branch, though, of pursuing particularly data science career is just kind of branching out more into, I guess, like, traditional is probably the wrong word for it, but more of what I think we think of data science today, such as like you were talking about with NLP processing and other sort of contexts that are more related to data science. Wouldn't also mind kind of being more kind of put within that space too. So yeah, I'm really at the beginning of the journey of trying to figure out whether or not I want to stay in business strategy and using data science to kind of help me much more as a business strategist, or kind of fork it, if you will, my career and head more data science path. So
that's a really interesting. That's an interesting journey already. So maybe how did you start into consulting? Like, what was the what was the main goal of entering consulting in the beginning, and now why are you trying to move away?
Yeah, it may be similar to you. I have always really been interested in education. Started my career as a teacher, actually, working with high school students. Was an English literature teacher, focusing a lot on writing, literature analysis. Did that for a couple of years post undergrad. Knew I wanted to go back to school to kind of switch up careers, and so obviously grad school is a great way to do that. Business school seemed to be like the best fit for me. So I went to business school, and like a lot of business school grads, it's typically consulting or something in financial services. And consulting has been like a great fit for me. It's kind of like a mixture of high level strategic thinking, while at the same time some data analysis as well. What I think is really interesting about consulting right now is I feel like it's kind of and maybe it's been like this for a few years, but kind of like the echelon of integrating more of what we consider to be maybe traditionally in the past, like data science type of skills, into those core business strategy skills. For instance, a lot of like econometric modeling, oftentimes you can do right now in Excel. Like for most of the work that I've done as a strategy consultant, obviously as you're working with more and more data and more and more data sets, like that becomes a much easier problem within R or Python or some sort of quote unquote like data science ecosystem. So I think increasingly, like, folks in business school, if they're not already, like, will be picking up Python and R and kind of understanding like the data science journey. And I feel like now has been I'm about 5 years into being a consultant. I feel like now is a pretty good time to kind of double down a little bit more on this core skill sets related to data science.
I love that journey. In fact, my high school English literature teacher was like the most influential person in my life at that point. Like he had an incredibly like diverse path, and then he eventually fell into education, and then he was kind of like he had a big bushy beard, and so I worked with an artist friend, and we put his beard onto a shirt, and then the whole class hit the silhouette of his face. We loved him. But yeah, that's an amazing story. Let's see if we can maybe gauge your SQL and Python knowledge. So have you started that path of learning a little of SQL, learning a little bit of Python?
Yeah, definitely with Python. SQL not as much. I'm familiar, I forget the name of the package in R, but it kind of like leverages high-level SQL commands. So via like the R interface, if you will, I could do some of the joins that are typical of SQL. With Python, I'm like at 25% into the Coursera data science, the really popular like data science concentration through the University of Michigan.
Yes.
So it's going well so far, but still kind of like at that foundational stage of working myself through NumPy and Pandas and Matplotlib. So it's not too different from what I was used to in R, but it's the syntax is still a little bit different, and obviously like different packages.
So in terms of Python, I have two questions that maybe we'll just do one or the other. One is going to be a little more like data cleaning. So they're both going to be very simple, enough to be able to solve in 5 to 10 minutes. But the main idea is one is going to be a little more about how can you clean data given a novel problem. A creative solution would be necessary. And the other one is more logical, right? You don't have to know any Python. In fact, it just involves you thinking about how to iterate through a process, and then I'll coach you through it. It's more of like a logic puzzle that you might solve, like a Rubik's Cube, for example. So which of these do you have affinity to?
Maybe I'm kind of curious, like trying the more Python specific ones, like the first one.
Yeah, let's do it.
Depending on how I perform, maybe I'll go with number 2.
So this question is going to involve a phone number. If you've been on Craigslist before, you sometimes see phone numbers of, I don't know, maybe righteously, like correctly suspicious people who don't want to put their phone numbers on as digits because a bot might scrape it up. So you have people who would put, 1, 2, but maybe then they go back to numeric 3, 4, and then they go back to written English 5. That's troublesome, because if we are a malicious bot, then we can't even pick up their number. We don't know what that is. So I would like to see if we can write a function that takes phone number and then outputs it as this. Takes in any amount of a combination of words and numerics, and then puts it out as only numerics.
Oh, thanks. Okay. Oh, there we go. Yeah, I don't think I'm probably to the point where I could unfortunately do this.
Would you like to do the other problem instead?
Yeah, that might be better. Though I am definitely interested in like how you would solve this one for sure.
Well, we would definitely solve this one together in mentorship. But let's talk about a different question. Let's talk about this question. Let's have a kingdom where a king rules, and it's a place where there are subjects living here, and the subjects are represented by a list of tuples. And you don't have to worry about what that means. All you need to know is that there is a list of an array of people, and they're represented by their name, which is the first element, and then their income, which is their second element. And each person in this kingdom, each tuple, has the same income. So Jamie has 100, Doug has 100, except one person in this kingdom has 101. We don't know what their name is, but let's say that their name is Fraudman. So if that makes sense, let's write a function together that returns the name of Fraudman.
Okay.
Of course, you don't have to write the function itself. Maybe let's talk through it and see if I can help you write the function.
Okay. Quick question: Would Fraudman's name ever change, or is that it's kind of set in stone, like he would always be that?
Yeah. So Fraudman is just a moniker. We don't know what his name is, so it does change, or at the very least, it stays the same, but we just don't know what it is. So we're trying to find it.
Okay.
Now, the only thing that differentiates him from everyone else is that he makes $101 instead of everyone else, which makes 100.
Right. Okay. So it would be safe to assume then that in order for us to identify "quote unquote" Fraudman, it's always the individual who would have the highest of the salaries.
Correct. That's right.
Right. Okay. Okay. So definitely we'd want to set up some sort of, we want to find the highest, kind of give within the function itself, we want to make sure that we always are returning the highest tuple, essentially. And yes, that highest tuple would be, the item that we're looking for. So, so should we create a variable, I guess?
Well, before the variable, before all the syntax and the nasty Python that we have to actually do, let's think about the logic. So what are we going to do to find this person? Let's imagine that it's just a list of names in a folder. And in this folder, you're trying to find the Fraudman. Now, what's the dumbest way? Let's think of a brute force way of finding Fraudman.
Yeah, I would just, I would assume anything that's bigger than 100, right? So we would just set up a logical expression. If this tuple is greater than 100, then it's the tuple that we're looking for.
That sounds good to me. So that seems like you're iterating through a list. Let's name this guy Fraudman. And immediately let's return it. Right. So this is just an if statement. We don't have in each individual subject, so we need a for loop. So for subjects, if the subject makes more than 100, so this is the index 1, which indexes the income, then set the name of Fraudman equal to their name, and then return it.
Right.
Right. So there you go. That's a brute force method. We did it, but this might not be super efficient. Do you know about time complexity?
No.
That's okay.
With Python or?
So time complexity is a concept that is in computer science when we scale code. It doesn't have to be Python, doesn't have to be SQL. It's just how the question is here. What happens to the runtime of this function when the input array is double?
Oh, okay. Got it. So, right, I think I was just reading about this recently, is that you definitely want to have, if we're working with pandas, you want to use, or NumPy, leverage one of its inbuilt functions as opposed to for loop. Because when the tuples get too large, then it just simply takes much longer to iterate through the for loop versus calling, a pre-baked function that's maybe already in NumPy to return. Yeah.
And so let's do an example then. If there's 4 people in this subject list, we'd have to iterate through 4 people. And if there were 8 people in the subject list, we'd have to iterate through 8 people, right? In a worst case scenario. So what is the relationship between runtime of this function and the size of the array? We call that big O.
Oh, it would just be 2x, right? I mean, I would assume.
Yeah.
We're at, or like
It would be
what the-
2x when the array is 2x. So that is a linear time.
Right.
So that is our brute force method. And we could be done here, but usually I would like you to find a more efficient way to think about this. And actually, I'm going to give you a clue. The king wants to give you some help. So he has defined a helper function for you. You don't have to know how this function works. But essentially, it takes in a list and then another list of the exact same format of the subjects list. So a list of tuples. And then it returns whichever one of these two lists has more income cumulatively. If they're equal in terms of income, then it returns false. So all this helper function is doing is summing up all of the income in both lists and then telling you which list has more income.
Okay.
So given that, let's come up with a more efficient answer. Call this answer 2, electric boogaloo. All right, is this turning any cogs?
Yeah, definitely. So, okay. Actually, no. I was following it, and then yeah, looking at no, yeah, unfortunately not. So I guess the question is then that you're looking for is basically what is this intervening line between this or something different?
So this might help you think of an algorithm. This algorithm I'm looking for is binary search, but the idea comes logically from the idea that right now with this answer, right up here, you are comparing each individual element of the tuple to a constant number, which means you have to look at every single element, right? But what you could do is just compare each of these two elements together, and then you would have half the work. Unfortunately, having half the work is still linear time. As the array doubles, then you'll have double the time complexity anyway. So that didn't really help. But what if you did compare these two guys to these two guys? Okay, that's half the list to each other.
Right, got it.
And by comparing half the list to the other half of the list, then you are actually reducing the amount of information that you need to search by half, and then half again, and then half again. That's binary search, and therefore it's no longer just cutting the search time in half, it's cutting it by an exponent.
Right, okay. Is this the same concept as downsampling?
You are catching me with a term I have never heard of, but it sounds like along the same vein.
Okay. All right, great. And this is called binary search. Okay, that makes a lot of sense. Yeah.
Now here's another tricky question.
Yeah.
So now that I've introduced that concept, I want you to do this with a length of subjects of 81. What is the time? How many times do you have to use this helper function when the length of the subjects is 81?
Okay. I think it's 5, but let me double check. And this is assuming that you wouldn't. This is assuming that you. Well, yeah, never mind. Okay, 6.
Yeah, 5 or 6, right?
Yeah.
So now the new relationship with this is that every time you double the the size of the array, you only increase the number of times we need to use the king scale by 1. So that's a new relationship, and this relationship is called logarithmic, which is the opposite of exponential. So log of n. Now, logarithmic is good, but 5 or 6 is actually not the minimum number of uses for this scale, and that actually will come with a revelation that you can't cut 81 in half. You probably realized this when you were doing your quick napkin math, is that you have to cut 81 into 3 groups at least. So what did you cut? How did you cut 81 in the beginning?
Yeah, I was just dividing by 2 all the way through, but then to your point, I think that's why I added an additional 1. Is that when you get down to 5, you need to, obviously I rounded up, so.
Right, but can you compare a 2 and a 3? You have to compare even-sized groups, because a group of 3 people will always have more income than a group of 2 people.
Right.
So in the very first cut, when you have 81 people, you probably cut it 40-41, and then you compare the two 40s together. Now, what are the 3? Now we're starting to talk about a little bit of outcome theory. Is that there's 3 outcomes here. Either the first 40 is heavier, the second 40 is heavier, or they're equal. In which case, then you've randomly picked the right person out of the 81 people, and that's the one person that you didn't put into a group of 40. Is that track so far?
So far, so good. Yeah.
So if you can start splitting this into an even number of 3 groups, then you would have the same process of elimination in your outcomes. You would have either the first group be too heavy, the second group be too heavy, or they're equal, which means the third group is too heavy. And then you can cut it again in 3, and cut it again in 3, and then surprisingly, you're down to 3, which means you have to cut it 1 more, and then you're done.
Right.
So the secret hidden math is that 81 is actually 3 to the 4th power. So the minimum number of times to use this king scale is 4.
Okay. Which should be obviously quicker than the binary.
This is still binary search, surprisingly. This is just now splitting into 3 groups instead of 2.
Okay.
But we used extra logical math when we thought about so being able to be coached into the idea that half of this doesn't make sense. You can't compare 40 and 41. You have to have 3 groups, would then lead you to logically think, well, what happens to 3 even groups? Now, very few people actually get to that conclusion. So if you're able to be coached into that conclusion, then you know that you're in the right path to acing the data science interview.
Wonderful. And this would this fall underneath the category of just like super basic algorithm design, or how would you categorize kind of like just this logic here of how this might come up in an interview?
Yeah, I would categorize this as algorithmic identification. Can you identify that this requires a specific, if you can understand that this required binary search, that would be 1 point. And then the next point would be, can you understand that that you need to be able to split it into 3 even groups as a advanced binary search. And then third would be, how is your code syntax, right? We would actually want you to be able to code this out into Python, which actually requires a recursive function. So you would have to be able to know how to write recursively in Python.
Right. Okay.
So that was a quick gleam into the data science interview. I think that all in all, you did a really good job communicating your thought process. And there's a lot to cover in terms of the breadth of a data science question that we can possibly cover. So in essence, I'm happy to answer more questions here, but just for the sake of the interview, I'm going to stop editing right around here, and I'm going to open it up to any questions you might have, maybe just like 1 question. So do you have any questions for me, Jamie?
No, I really actually appreciate kind of like you going through the thought process with me. It gives me like a really good high level point of view of just kind of like some of the basic, like a basic 5 to 10 minute exercise I would need to be able to complete well in order to kind of get to the point where I would feel comfortable, interviewing for a data science position. So yeah, less of a question, more of a thanks, if you will, for kind of walking me through that.
Nice. Well, we'll keep you posted on the data. I hope that you keep us posted on your progress in the data science journey, and we'll catch you when you report back in a couple weeks.
Yeah, definitely. Thanks so much for the context. Would love to follow up with you on that. I guess I'm very much at the very beginning stages, if you will, of kind of like trying to chart out like what my data science career could look like. So, would need to, I guess, just do some thinking behind that. But it would be really fun to work with you. I think I'd learn a ton. So, we'd appreciate it if you could just follow up. Or keep in touch, like by email, and talk about next steps that way. It'd be great.
Awesome. Thank you, Jamie. This was a great call. I think you have a really fast learning curve. So the coachability aspect was very high in your call. And that's honestly as much as data scientists want to differentiate themselves from software engineers, they're kind of antisocial. They're kind of, they think inwardly and they don't have the right communication skills. So you already have those beat by a long shot. So let me send this email to you, and then we will talk either through another call or through the messaging app.
Okay, well, wonderful. Very nice to meet you, and look forward to following up soon.
Good to meet you. Thank you, Jamie.
Okay, bye.
Are you still there? To delete this message, press 7. To save it in the archives, press 9. To hear more options, press 0. What are you talking about?